I'm going to be talking about superposition, but to be able to use that method, your circuit must be, let me see if I can highlight that, must be a linear circuit. That means all the elements must be a linear element. What is a linear element? A linear element is any element that has a linear relationship between the voltage and the current. If you do the voltage versus current, it should be a straight line. For example, if you take a transistor, you'll find the voltage versus the current is not a straight line. So what we're going to be dealing with are linear elements. So if your circuit is linear, that means we can apply the principle of superposition. So what is superposition? If we have this example.
So is this saying like not all things obey Ohm's law?
Huh?
Like not all things obey Ohm's law?
Well, that's true. There's some elements. Well, Ohm's law says increase. If you increase this, you increase that straight line, linear. Sometimes it's not linear. Transistors are not linear. Diodes are not linear. So let me take some sources. Put, let's say, 2 amps here. I'm just making that up. And I have a resistor. It's not really a popular method of doing problem here. You'll see why, because you got to do the problem in this case twice. And I'm going to change this. Well, instead of a current source, I'm going to make this a voltage source. And let's assume the question here, find the current coming down here. What is that current? Now, notice if I label this as reference, the bottom, I know what the voltage here. I don't know what the voltage here. So how many nodes you don't know the voltage to? 1. That'll be how many equations by how many unknowns? 1 equation by 1 unknown. Do it that way. If you decide to do KVL here, or mesh equation, you know what this current, this is 2 amps. You don't know this one, you don't know that one. How many unknowns? 2. How many equations? 2. But I'm going to do the problem with superposition. Superposition says, you know what? If you want to find the current through this, do it to this source and that source. Do them as 2 separate problems. Find the current due to the first source only. And we need to kill the voltage source. When you kill a voltage source, you make it a short circuit. So we'll call this current I sub 1, or I due to source 1. Then you're going to add to it, find that current. Then the second part is you're going to kill this source and find the effect of that source on it. So let's find the effect of that source. That will look like this. And when you kill a current source when you kill it, an open circuit. We'll call this I2. So I is really the current I'm looking for is the sum of them, I1 plus I sub 2. The current due to source 1 plus the current due to source 2. When you kill a voltage source, you make it short circuit. And when you kill a current source, you make it what? An open circuit. So you can see if you have 3 sources, you got to do the problem 3 times. So let's look at this one. What's going to happen to that resistor when you put a wire across it? It's gone. Why? Because it's in parallel with 0, right? It's the product over the sum. What's 10 times 0? 0 divided by 10, that's 0. It's gone. So my circuit here, this will be 2 amps. This is the 2. And this is the 5. Doesn't matter if I put it on the top or down here. And can we find I sub 1? Current division, correct. I sub 1 is going to be the 2 times 5 over the sum of them, which is 7. 10 over 7 amps. Now let's look at that circuit. Find the current due to this source. And when we add them, that's the answer we're looking for. So there's the other circuit. Here we go, 5 volts. This is 10, 5, 2, and I'm looking for that current. If I know this voltage, I'll call it VZ. If I know that voltage, that's a Z here. Can I find what that current is? Ohm's law, right? Well, how do we find what that voltage is? Voltage division. There's 5 volts right here. These two in parallel. There's 5 volts right here. So VZ is going to be the voltage here, which is the 5, times that resistor, which is what? 2, over the sum of them, which is 7. And that's what? 10 over 7? That's the voltage. So what's I sub 2? Ohm's law says the current through a resistor, it's the voltage divided by the resistor. What's my voltage? 10 over 7 divided by 2, which is what? 10 over 14 amps. And we said if you want to find I here, you find it through due to source 1, find it through source 2, and add them. That's what I is. So now my I, the one I'm looking for, I sub 1 plus I sub 2, 10 over 7 plus 10 over 14, that'll be what, 20 over 14, plus 10 over 14, which is what, 30 over 14? Which is 15 over 7 amps. 2 1/7. Now let's see if that's really true. Let's see if that's true. Let me do this circuit using maybe nodal analysis. Same problem. I don't want to use superposition. I want to see if the math is correct here. We're looking for this current I. Let's assign current any direction you want to I sub x, I sub y. This is your reference. This voltage here is what? 5 volts. This voltage here is what? unknown. We'll call it V. So how many unknowns do you see there? One. One equation by one unknown. If I do the current entering this node, should equal the current leaving that node. What's going to that node? The 2 amps. It's going in. And what's leaving that node? I plus what? I sub x. 2 equals, what is I? It's this voltage V minus nothing divided by 2. What is I sub x? It's going that direction, so it's V minus this voltage 5 divided by 5. What's my LCD? 10? 20 equals 5V plus what? 2 times V minus 10, or minus 5. Distribute that. Bring it here, that's 30 equals 7V. What's V equal to? 30 over 7. If you know the voltage, can you find the current? I equals V over 2. 30 over 7 divided by 2, which is what? 30 over 14, which is 15 over 7 amp. Is that what we got before? So superposition says if you have more than one source, find the effect of each source separate and add them. Now, obviously, if one is pushing down, one pushing up, instead of adding them, what do? You subtract them. But if you define the current, both cases coming down, whatever 2 numbers you come up with, you just add them. Let me try another one with superposition. Sometimes we end up being lucky where when you actually kill some of these sources, the circuit becomes really simple, straightforward. Here's the problem I have. I have 10 volts here. Two ohms. Three amps. One. Two I sub x. And the question is, determine the current I sub x. Find I sub x. We're going to use superposition. So first, I'm going to break it down using this source alone. So this is really gone. I don't even have to put that. That's what my circuit will look like.
So you don't short that one?
No, current source, open.
Oh, so you didn't do current source or voltage source?
You're going to find the effect of each one. I'm looking at the voltage source first. That means when you need to kill the current source. When you kill a current source, you make it open circuit. When you kill a voltage source, you make it a short circuit.
So you wouldn't kill the one on the right too?
I am. I'll do one at a time, not both. So you only have two sources. You can't kill this one. That's a dependent source. If you just put that source by itself, there's nothing. It needs something to power it. So I get two sources. Let me find the current due to this source, and that's what I'm doing. Let me also kill this and find the current due to that source. So the second part, I'm going to do it twice. So this current, I'm going to call it I sub x bar. That's due to source 1. I'll go bar like this. And now let me kill this source, the voltage source. When you kill a voltage source, it becomes a short circuit. And this current here is really I sub x double bar. So this source here, that dependent source, in this case, because they killed that one, it becomes I sub x double bar. In this case, it'll be I sub x bar, because that's the only one you have. You don't have I sub x. That becomes this one. So we're going to find the answer to source 1 plus the answer to source 2. So what is I sub x? It's going to be I sub x bar plus I sub x double bar. If you know what these values are, you found your I sub x. Okay, let's analyze this one. That looks like one loop, doesn't it? Perfect. KVL this way. There's only one current. That's really I sub x bar going through it. KVL. That's negative 10 plus, what's the voltage drop here? 2 times I sub x bar plus 1 times I sub x bar plus this one, 2 I sub x bar, is equal to 0. Look how easy that equation. What do we have? 5 I sub x bar equals what? 10? What is I sub x bar? 2 amps? Now let's look at the other circuit and see what we're going to do with it. So this solution is due to this one. Let's look at the other circuit. Two I sub x double bar, 1, and you can use any method here you want to use. And this is I sub x bar. Double bar, I guess, right? This is 3 volt, okay. So if you want to do KCL at this node, let's see what we know. This is your reference. This is a voltage source. See that voltage source? That tells you the value here is 2 times what? I sub x double bar. So the only value that you don't know what the voltage is this one, V. And let's assume this current's going that direction. We'll call it IT. KCL at V. KCL at V. The current going in, what do we have going in? I sub x double bar plus the 3 amps plus equals the current leaving, which is what? I sub t. Now, reference usually has a value of 0 voltage, right? So let's see what is I sub x double bar. It would be even easier. KVL right there. I'll show you that after. I sub x double bar is going to be what? 0 minus V divided by 2 plus the 3 equals I sub t, which is what? V minus 2 times I sub x divided by 1. LCD is 2. Bring the minus V here. 6 equals what? That'll be 3V, right? I sub x double bar here. Now, going again, we said what is I sub x double bar? It's 0 minus what? V divided by 2, which means 2 times I sub x equals negative V, or V equals negative 2 times I sub x double bar. From right there. I sub x double bar is this minus that divided by 2. Now if you do that substitution here, 3 times instead of V, that's negative 2 I sub x double bar, negative 4 I sub x double bar, negative 10 I sub x double bar. What's I sub x double bar? Is that negative 0.6? And I'm done now. What is I sub x? And the first one we answered due to source 1, what was it? 2 amps plus a negative 0.6. What do we have? 1.4 amps. Again, this is not a popular method because you end up doing the problem 2 times or 3 times if you have 3 sources, 4 times if you have 4 sources.
So it's not a popular method because it's not that useful?
Well, because you do the problem more than once. I mean, notice I could have did the problem with just KCL from the beginning with putting that source there. It's not going to change it by much. Actually, if I go back and put that source in, it really didn't change anything in terms of doing it this way. You know what the difference? What is the voltage here? 0. What would be the voltage here if I did it? 10. So if I just put 10 here, I just solved the whole problem without breaking it down. Again, sometimes when you actually kill some of the sources like this was not bad to solve. In some cases, not a bad way, but sometimes you end up doing, again, twice the work, 3 times the work to get the same answer. And I don't want to do that work there. So what's another method that might be of interest to us? Besides, that's called superposition. The next method is called source transformation.